Hi guys, there was a question from one of the homework assignments from section 3.3, problem number 139. So the student asked about this problem. Also, he noticed that there were no videos, lecture videos or example videos on section 3. I'm not sure how did that happen, because usually I try to include the videos for every section. But anyway, I'm going to try to add a video or two for you for this section also, just so you have another, I guess, lecture video on this section. And I'll let you know as soon as I do that. But for now, the student also had a problem with this problem number 139. So let me just work that for you. So the instruction, by the way, says integrate using the method of trigonometric substitution, which I'm sure you read the section carefully. You understand what that means. Then it says to express the final answer in terms of the variable. So what they mean by that, of course, so your integral is dx, integral of dx over x squared times the square root of 1 minus x squared. So what they mean by the last statement is that obviously this integral starts with the variable x, right? Now you can make your substitution, bring in any letter, theta, alpha, beta, whichever letter you want to use to name your angle. But then at the end, make sure your final answer is in terms of the original variable. In this case, of course, x being our original variable. Okay, so that's what they mean by the last statement, to make sure express the answer in terms of the variable. They should have said the word original variable. Maybe that will make it more clear. But obviously, in this case, our original variable is x. Anyway, so we're going to let, so if you read the section carefully, if you look at what's on the square root, so the whole point behind integration by trigonometric substitution is to try to remove the radical, the square root in this case, and of course, hopefully that will lead you to integrate. Now, one way to get rid of square root is to end up with something squared. This is why in this case, your substitution would be, of course, x equals to sine of theta. Now, why is that? Because when you square sine, remember that becomes what? Sine squared. And of course, 1 minus sine squared by one of the Pythagorean identities from trigonometry is cosine square. And once you have a cosine square under the square root, of course, the squares cancel with the square root and you just get cosine, okay? So from here, of course, we do need dx. I'm going to go ahead and find dx. So if you let x be sine theta, of course, the differential of x, which is the derivative of this function, or the derivative of sine, of course, is cosine. And then don't forget your d theta, right? So this is our dx. Because remember, we're going to have to change all the x's to thetas. We can't just have x and theta at the same time. Now, at the end, they want the answer in terms of the original variable x. Okay, so now we're going to go ahead and realize that, of course, 1 minus, I'm just going to go ahead and reduce this right here. So we have a square root of 1 minus x squared. And since we let x be sine theta, that becomes a square root of 1 minus sine squared, which again, as you know from trigonometry, 1 minus sine squared is cosine squared. And of course, you cancel the square with the square root. So at the end of the day, the square root with our substitution just become cosine. Now x already is sine. So now we are ready to go and write this integral in terms of theta only. So the dx, remember, became cosine theta d theta all over x squared, which of course will be sine squared in this case because x is sine theta. And then times the square root of 1 minus x squared, which of course turns out to be cosine theta. So as you can see, you can cancel the cosine with the cosine. So at the end of the day, you're left with d theta, I should say integral of d theta over sine squared. Let me just kind of pause for a second there. So now we're going to, of course, integrate this. So I'm going to move it upstairs here. Okay, so from here, I'm just going to move it up here. Now remember, you can rewrite that, of course, as integral of 1 over sine squared, and then, of course, d theta. But remember, there is another name for 1 over sine squared from your trigonometry. That's the same thing as cosecant squared. And this is why I told you that, always trigonometry and algebra always has to be part of your memory, because calculus relies heavily on algebra and trigonometry. D theta. Now, as you also know from your calculus 1, the integral of cosine square, of course, is negative cotangent theta. Don't forget your C. Now, let me just pause here for a quick second. I'm going to need this substitution in just a second, but I'm going to take everything else off. I mean, you have it in your video anyway. So now the question is, how do I write this answer in terms of x? Because remember, at the end, they want the original variable, which was x. So we're going to do a little bit of observation here. Don't forget, anything can be always written as over 1. It doesn't change its value. Since sine is x over 1 or just x. Now remember, at this stage, you're going to draw your what's called a special triangle. So this is your thing. Let me just kind of draw it the other way. Easier to see. So we have basically our special triangle or reference triangle. So if you think of this as your angle theta, now remember, what we do know is sine of that angle is x over 1. Now what is sine? Opposite, so that will be x, over hypotenuse, right? From Pythagorean theorem. So that will be your hypotenuse, which is 1 in this case. So now remember, we want cotangent. Now what's cotangent? Cotangent is adjacent over opposite, right? Which is reciprocal of tangent. So we need to find adjacent, of course, by Pythagorean theorem. That will be hypotenuse square, which is 1. The square minus the other side is square. But of course, 1 square is just 1. So we can just write that as 1 minus x squared. Okay, so that becomes your adjacent to angle theta. But remember, what's the definition of cotangent? Cotangent is going to be, the negative is still there, of course. Cotangent is adjacent, which in this case is the square root of 1 minus x squared over the opposite, which is just x. Don't forget your c. So this is how you finish, because now you have write the final answer in terms of the original variable x. Because remember, we brought in theta to help us to integrate, but at the end they want to make sure you change it back to the original variable, which is x. Okay, so there's your final answer. I hope that helps.